So, chapter 3, and we are going to start talking about a different measurement for our angles. So far, everything we've been looking at is degrees, and we do want to switch that now and start looking at what a radian is. This is probably the more common measurement. If you take any higher math class, we always have to look at things in radian form. Okay, so in a circle, if I found an angle that cut off an arc, so an arc is talking about the outside of the circle, where that length of the arc and the length of the radius are the same, that is the definition of a radian. So a radian is the size of the angle needed so that the radius equals the arc length. So when I'm talking about 1 radian, that's the angle where the radius is equal to arc length, which we denote with S. So to find that measure, our angle, so as I move around my circle, the radius never changes, does it? But the arc length will get bigger. If I take a bigger angle, the arc length grows. So to find out how many radians, all we have to do is take the arc length, S, divided by the radius, R. So theta equals S over R. S is arc length, R is radius, theta is the measure in radian. When you are dividing those, the arc length and the radius have the same unit. They're both lengths, so if they could both be in inches or in feet or something like that. When you divide those the units will cancel. And so technically a radian doesn't have a unit with it. You can write the word radian, but from now on, anytime we see a number without a label, we are going to assume that is a radian. So if you mean degrees, you have to put a degree symbol. If you mean inches, you have to write inches. Anything without a unit is going to be assumed to be radians from now on. So just a basic example to get us started. If I had a central angle in a circle with a radius of 3 and it cuts off an arc length 6 centimeters, what is the radian measure? I told you the radian measure is just S over R. S is the arc length. What is the arc length here? 6. R is the radius. What's our radius?
3.
So my angle is 2. You can write the word radian, but you don't have to. If I just write a plain 2 with no degree symbol, I am assuming you are talking about radians. Now, what we really need to be able to do is relate the two forms of measurement we have. We have degrees, we have radians. They're both talking about circles, so we need to be able to go back and forth between them. So, let's think about a circle. All the way around the circle is a full rotation, right? If you go all the way around, your arc length, the distance around the outside of the circle, is your circumference. So your angle, which we know is S divided by R, will be the circumference. What's circumference of a circle? Does anyone remember how to find that?
Pi times the radius or something.
2 pi times the radius, yeah. Circumference is 2 pi R divided by R. And what's going to happen?
R's are going to cancel out.
Yeah. So we know a full rotation is 360 degrees. And in radians, the r's cancel, and we just get 2 pi. So 360 degrees is the same as 2 pi radians. If we reduce that, we could divide both of those by 2. So 180 degrees is equal to pi radians. This is going to be the conversion that we use. I'm not going to ask you to recreate that. I just wanted to show you where it came from. That's not just something I made up to make math fun. It actually works. 180 degrees is equal to pi radians. That's how we will convert between them. So this will probably be might be our last example for today. I just want to convert each of these things into radians. So if we have degrees, we know that 180 degrees is equal to pi radians. Now we've done some conversions before, haven't we? If I was taking like 20 revolutions per minute, and I wanted you to convert that into revolutions per second, we would say, okay, I know 1 minute is 60 seconds. And why did I put my minutes on the top? Then they cancel. So if I want to change my 45 degrees into radians, I know 180 degrees is equal to pi radians. Would I want my degrees on the top or bottom? Bottom, because this is on the top, I don't want to cancel it. So I'm going to multiply by pi over 180. On your calculator, if you use the pi button, it's going to sub in the decimal. And we're going to try to avoid that whenever we can and keep things in terms of pi. So we're going to use the calculator, but we're not going to put in the pi. So we would multiply this, the degrees drop. So you get 45 pi over 180, or do 45 over 180 on your calculator. And put it in fraction form. And what does that give you? So it'll be 1 pi over 4, or just pi over 4. So 45 degrees is equal to pi over 4 radians. So 450 degrees, how do we change that into radians? Always 180, because pi radians is equal to 180 degrees. Right. So we have basically 450 over 180, and then we'll just tack the pi back onto our answer. And what's that give us? 5 pi over 2? That's good. And it doesn't matter if I give you decimals, if I give you positives, negatives, we do the same thing. So negative 78.4 degrees multiplied by the pi over 180. So those degrees cancel. So we have 78.4 over 180. And that one gives me 98 pi over 225. Now, could we give a decimal for these? Absolutely. If you wanted to type 78.4 pi over 180, you get 1.368. It doesn't matter. It doesn't have to have the pi symbol still in it to be radians. When it's giving us nice fractions like 1/4, 5/2, it's easier to stick the pi with it. When you have decimals to begin with, sometimes we might multiply it out. It doesn't matter. It's not the pi that makes it radians. It's the fact that we don't have a degree symbol. That means it's a radian unit. Any questions there? Do you want to do one more, or do you want to stop it?
You can maybe go on.
Okay. Let's just turn these into degrees. And I don't know why this is supposed to be pi over 6. I don't know why it looks funny. So pi over 6 is radians. So what am I going to multiply by to get that into degrees? 180 degrees over pi. We just flip that fraction. So my pi's drop. I have 180 divided by 6, which is 30 degrees, but we have to put that degree symbol. I've been kind so far writing it in if you leave it off, but now we have to have it when we mean degrees. Four pi over 3. If I want to change that into degrees, we multiply by my pi's drop. So I have 4/3 times 180, which is
240.
C, negative 4.5. It doesn't have a pi on it. Does that mean it's degrees? No. If I wanted to be degrees, I would put a degree symbol. So this is radians still. So we're still multiplying by 180 over pi. If we can't cancel the pi's this time. If you did negative 4.5 times 180, you get negative 810 over pi. Or if you actually multiply that and divide it by the pi, that is a negative 257.831 degrees. And you could write it either way, whether you divide out the pi or not. All right, so that's our stopping